My name's Nicolás Young, and I'm a research scientist here at Lamont-Doherty Earth Observatory. I'm a geologist slash paleoclimatologist. I do most of my work in the Arctic, and my primary focus right now is on two projects we have going in Greenland called the GreenDrill project and the GRate project. And so these are two very related but complementary projects. So GreenDrill is focusing on drilling through the ice to collect bedrock, which is a really big engineering feat. And so that bedrock can tell us something about how the ice sheet has changed in time. And we're thinking about sort of hundreds of thousands to millions of years timescale. Then the GRate project is really interested in how the ice sheet has changed pretty much over the last 12,000 years. So much more recently, a little bit easier to get those data, but these two projects are very closely related since we're interested in what the ice sheet looked like during past warm times, whether it's the last 12,000 years or whether it's 400,000 years ago. Yeah, so some of the biggest changes on the globe are happening in the Arctic. And this is mostly due to the loss of both land ice and sea ice. You know, ice bounces back a lot of the sun's energy. And so once that starts to melt and the Arctic surface becomes darker, it sort of turns into a somewhat of a runaway warming scenario. And so we're really trying to figure out how these rapid changes in the Arctic are going to manifest over the next, several hundred to thousands of years. I feel like the challenges are usually, technical and logistical. Whether it's an engineering problem that it takes a lot of people thinking a lot about to try to solve, or when you work in the Arctic, nothing ever goes how you think it's going to go, and a lot of that is related to logistics. It can be pretty isolating, especially if we're going for long periods of time. I've done field stints anywhere from 2 weeks to 10 weeks. And it can be physically demanding as well. The spring up there is still basically our winter here. And so it's cold and you can eat pretty much as much as you want, but you're almost guaranteed to still lose weight because the body just burns so many calories trying to keep itself warm. And once you've spent a few weeks up there, it really starts to wear on you. But in the end, it always works out. You just need to be flexible. I'd say one of the most rewarding was probably this past spring. It was a very long and hard season, doing a lot of work that we don't typically do. And so we had a lot of people cycling in and out of the camp. And there was a long stretch of time where we didn't think we were going to be able to drill through the ice and collect the samples we wanted. And in the end, we actually did get the samples, but by this point I had already come back to New York since my shift was done, but receiving the updates from the field saying that we were able to get those samples was pretty good. A lot of people think of the great ice sheets, such as Greenland or Antarctica, as being these really stable bodies of ice that frankly don't do a whole lot. And I think what we've learned over the past several decades is that they're very active. They change on rather quick timescales, at least geologically. And I think it's important for people to realize that if we're talking about changes of ice sheets on the, say several 100-year timescale, that may not directly relate to them, but it will directly relate to, either their children or their grandkids. And so I think making it clear that we've learned that these ice sheets do change quite quickly, and that people alive now will nearly feel the effects of this is pretty important.